I'd like to talk to you about a proposed advanced placement computer science course called APCS Principles. This AP course is designed and has been piloted this year at the University of California, San Diego as a general education course. And that is, it's required across all majors, and this year has been taught to over 1,000 students. The goal of this course is to define and to teach what all college graduates need to know about computing in order to become leaders in our global society. This course has been defined by 7 big computing ideas, and then it is instantiated through getting students to develop 7 computational thinking practices. The core of these computational thinking practices is that students be able to create computational programs and to use abstractions and models. But these skills, these thinking practices, really serve in building some higher level skills. That is, that all students need to be able to analyze problems and programs and to communicate processes and results regarding technology, no matter their field of study. Of course, these then also, along the way, allow us to get students to be able to analyze the effects of computation on society and the world around them, while also effectively working in teams. But our course particularly focuses students on the analysis of problems and programs and communicating processes and results, because it's being able to understand how a computer works on those crazy everyday problems that you have, and to be able to talk about your problems and your results with other people that we think is critical. Now, what do our students actually say they get out of the course? To what extent their learning goals are achieved depends on how they tell us how they're different at the end. And many of our students report increased confidence. The student says, it has given me the confidence that I'm able to figure things out on a computer that I would never have thought I could do. Others talk about their changed view of technology. Now, every time I find myself playing a video game, I actually understand what makes it work. That these games are not magically produced, that it takes time, skill, and sufficient funds to create these games. I appreciate these games more than before taking this class. They also define analysis skills that they've learned. We learned in Alice that computers do exactly what you have them do. Using this knowledge, we can understand how programs like Excel and numbers work, and learn that when we are using these programs, we need to specify and be exact with what we are doing in order for the program to meet our needs. They also identify how these analysis skills may transfer to other areas of their life. Programming allows a person to think more logically. Thinking in order and debugging allows the user to gain valuable problem-solving skills. Aspiring to go to law school, thinking logically is extremely important, and I think that this has helped. Also identified how the skills transfer to math. I feel that learning the language of computing definitely helps you understand dense reading a lot more efficiently. I personally have noticed that my in-depth understanding of computer science wording has helped me understand my mathematical theorems and proofs more regularly than before. Communication was something heavily emphasized in this course. In today's technologically centered world, using a program like Alice, the programming language we teach, gives us valuable exposure to discussing things technically with other people and explaining clearly what we are trying to do. And finally, students developed organizational skills. Through Alice, I learned to stay organized and structured in anything I do, including studying for other classes. Although at first thinking with several concepts at a time is very difficult, now I'm more confident. So what we actually did was we did teach students to program using a drag-and-drop graphical programming language called Alice, and then we got them to apply those same concepts in Excel. But really, this course is about getting students to develop analysis and communication skills. We don't just want them to be able to program. So we don't just have them come to class and listen to us explain programming concepts. Instead, we want students to be able to analyze how a computer works through using a simple graphical programming language. We want them to be able to understand that you can, in fact, analyze what a computer does, that you can have something that doesn't work, make a change, and then be able to talk about and explain how that change is going to affect the program. In the classroom, we support this by having our students engage in a pedagogy called peer instruction. They're presented a question about a piece of programming code and asked either what it does or how they would change it to do something else. They then spend their time discussing in groups and analyzing the code in front of each other so that they learn what makes a reasonable analysis. So they have the opportunity to communicate about technical issues that are challenging for them. And it's through this opportunity to work together and communicate in class that they build those skills that will be able to serve them as they go on to deal with communication and analysis tasks regarding any sort of technology in the future. And it's this comprehension we hope students take from the class.